Good evening to all of you. I'm here once again with a series on our car prediction model, evaluation and artificial intelligence. My name is Mugumbia Benon. Uh, I'm a student at Makerere University. So our problem statement for the problem we are trying to solve is we want to improve car sales through maximization. We want a model that can set the prices, predict prices that sellers and buyers can use for each of them to maximize sales. The project background, basically in today's tutorial, we are going to be discussing mainly about our concept paper. Talking about it, I'm going to upload the concept paper for you to take a look, but basically the project background, we first studied what other scholars have done. After studying what other scholars have done, we also came up with our own conclusion of we want to determine which algorithm is the best, is the most suitable for the price prediction. So we got work from different scholars, and we're going to run our own experiments and determine which algorithm is the best. So from here, you can see that many scholars have attempted to define suitable ways on how to effectively predict prices of used cars. Our project will basically provide more in-depth research on different machine learning algorithms that have been processed to assess the effectiveness towards the problem. The model we want to get the most precise model. So we are going to test the different algorithms that many scholars have gone through, many scholars have suggested. And now the project significance, basically we'll talk about how significant this project is to people. Why should people know about it? Or why would people take interest in this kind of research? So through our documentation on each machine learning technique results into accuracy as regards to car prediction models. So here we want to determine which algorithm is the best suitable for car price determination. More efficient models will be developed and deployed with an expectation of the best possible results. So here we want to assess them different techniques that can be used in this price prediction model to assess which is the best for our case. So that's the significance of our project, mainly to assess which algorithm is or technique is best for this kind of prediction. So the project scope here, I just want to talk about the things you are going to cover, maybe the expenses, basically speaking about what the project is going to cover and maybe cost. So project scope is mainly centered around assessing various machine learning techniques in order to generate the most efficient models as regards to car prediction. Different tests are carried out on the data set and different output results documented within our paper. So basically our project scope, we just want to understand the different algorithms and do various tests on these techniques while weighing generating different price predictions, then assessing the predictions against the actual current the current car value prices and see which one is which technique yields the value that's closest to the actual price. So we needed some leading questions to guide us during our research to help us better understand what we are doing, and basically to define more of our project scope and our significance. So some of the questions are: what's the importance of car prediction? Like, what would people want to know, predict the prices of a car? And one reasoning to this could be that people usually want to know this usually when they want to sell off a used car. We also wanted to know which algorithm would provide the best prediction, because people want to get something that's almost accurate, something that's close to the real value so that they can make a better judgment based on their budgets because they want to purchase. Then, which algorithm is most complicated to implement? Because you could have a technique on algorithm that is time consuming or space consuming. So we want to maybe get that. We may also maybe want to consider an algorithm, maybe based on the space and time it takes. Because maybe you want to build an algorithm, but when you have limited space and you want something that gives you almost accurate results, but takes the least amount of space. Then you also wanted which algorithms are quickest as regards to result generation. So we had to determine which algorithms yield results quickly. So those were some of the leading questions that guided our research. So we came up with an hypothesis as we were carrying out our research. The hypothesis that we made is that a machine learning model can be trained and developed to accurately predict the prices of these cars in a particular year. That's the hypothesis we are basing on mainly when you're carrying out this research. We're assuming that an AI model can be built, trained, and developed to predict prices. That's the hypothesis. And I think through our research and if it follow through with our tutorials, realize that we have actually managed to prove this hypothesis. It's a true hypothesis that we have proved as we go into the documentation. Our research objectives mainly, what was the main objective of our research? Like I've said, our objectives are set to establish whether machine learning models can actually predict prices of used cars, and determine algorithm and technique based establishes a price. Basically, we can put this in context, the leading questions, because our research questions were mainly could also define our objectives, because the research questions have a direct mapping to the objectives that we came up with for our research. In this case, we're talking about the concept or conference paper that we are developing basing on our research in a different algorithm that can be used to detect car prices. So we proposed an AI methodology, just one of like the most commonly used, called a multiple linear regression, which is one of the techniques that can be employed in order to make a prediction from independent variables to assess the dependent variables. So basically here you feed them, when you're training the model, you feed it with independent variables. Like for our case here, we have our data set as the weight of the car, the color of the car, the levy, all the different factors that may be considered when determining the price of a car. So those are the independent variables because they don't depend on anything. So we want to put all those independent variables together to assess a dependent variable. In this case, a dependent variable is the price. That is what we want to assess. So the independent variable like levy, the color of the car, the height of the car, the kilometers driven, the fuel type, all those independent variables are used to assess our dependent variable, which is the price. So in any case, we need a way of testing our model to see if our model is yielding the best possible results. So for this case, for the technique of linear regression, there's a testing technique that we refer to as the R-square. Now, the R-square can be used to assess the performance of this technique, as a high value of the R-square would imply a low difference between the model predicted price and the actual market variation. Sorry, excuse me. So the R-square usually is a ratio over the predicted price and the actual market price. Now, when you get that ratio, we can help determine and assess the performance of our model. Of course, this could be limited by many different hindrances within, because a biased data set may yield a very low R square. So the major thing here is to process our data set. We clean the data set in order for our R square to be effectively used to determine the, the, the performance of our technique. So here I've listed out the different references that I used when I was building the concept paper. There are about 20 of them, so you could go through the slides that I always keep uploading alongside the videos, and you compare and you can look through those different those different lines of thinking from other people who have done similar research for a better understanding of the concepts and verifying my research. Thank you very much. That will be all for today, and have a good evening. Thank you.